Hello students, myself Shamrat Paul. I am going to explain the topic on single phase, full bridge, voltage source inverter. Okay, that means we are going to use the bridge circuit during full bridge operation. So go to the circuit diagram first. Here we are using the bridge circuit similar to this one. Okay, the switch S1, S2, S3, S4 which will form a bridge, and here we are using a DC link voltage which is having the magnitude of Vs. In the previous section I have discussed about the half bridge voltage source inverter. Then the supply voltage was given across the load, that is Vs by 2, and here we are using Vs. Switch S1, S2, S3, S4 which will form a bridge for R mode operation, and D1, D2, D3, D4 again it will form another kind of bridge or diode bridge when we are changing the load further operation by RL load. In this operation, as the R load is there is no question for the charging and discharging path. That is why maybe the diode D1, D2, D3, D4 will not be conducted. But whenever we are going to apply RL load over here, then the utility of the diode will be found. Okay. So here we consider the two mode operation. When the S1 starts conducting, then the current starts flowing, that is through S1, then S2, and coming back to the supply which is reflected on this circuit. And in mode 2 operation, when the current starts conducting by S4 and S3, then the current starts flowing through this direction, S3 to load, then S4, and coming back to the supply. That is why we consider two mode operation. Okay, this one the first mode operation and this is second mode operation, and this is the respective output waveforms and output current, voltage and current. Here we are using two switches, that is why we should give the triggering pulse across the switch S1 and S2 at the same instant, and for S3 and S4 the same instant. But keep it in your mind, never try to give the triggering pulse across the switch S1, S4 or the switch S3, S2 at any instant, as it will provide a short circuit path. Then the thyristor of the switch can be permanently damaged. To avoid this damage, we will giving this kind of triggering pulse in this way. Now see, in the first mode operation, the duration is 0 to T by 2, and in the second mode operation, that is T by 2 to T. If we consider this is the complete cycle, okay, or this is the complete cycle which is defined by 0 to 2, that is why the half time is taken for the mode 1 operation and the remaining is for mode 2 operation. That is why when S1 and S2 starts conducting, then the current is flowing through the load in this way. Okay, and the voltage is appearing across the voltage. This is the polarity. Suppose it is assume the positive polarity, and the current is direct, and the current direction is your left hand side to right hand side. Suppose the positive current. That is why it is defined by this is the voltage when S1, S2 starts conducting. When S3 and S4 starts conducting, then the current is flowing this direction. That means what? The current is flowing with respect to the previous one now in the opposite direction, as well as the voltage with respect to the previous one, the polarity of the voltage is right now is this one. That is why it will give you the negative voltage and negative current. That is why this is the waveform of voltage. As we are using the resistive load, that is why the voltage and current both will be in same phase. That is why the output current which will follow the output voltage, right? And the magnitude of the current that should be equal to Vs by R, as the Vs is input voltage which will be reflected on the load. That means we can say during conducting V0 equal to Vs, that is why Vs by R. So this is the waveform. And considering this mode operation and the switching state, we are defining here 0 to T by 2, S1, S2 conducted, T by 2 to T, S3, S4 conducted. Again, the cycle will be repeated for the next onward. Now we are going to calculate the RMS value, and by using the Fourier series, we are going to represent the periodic function. As it is a periodic in nature, because the output voltage is just similar to a sine wave or periodical in nature, that will give you the periodic output voltage. As it is inverter operation, DC is converted to AC. Now the calculation part. See, first calculate the RMS value. We know the expression of the RMS value, which is defined by the root mean square. Similarly, we have done here, okay, that is the RMS value, VO RMS equal to 1 by T by 2, integration of 0 to T by 2, V0 square T dt. And further it can be simplified, where the V0 will be replaced by Vs, as the input signal is Vs. So after integrating, we will get the result similar in this way, that is Vs square, and considering the limit part, that is 0 to T by 2, so we will get the result, that is Vs. So RMS value that is similar to input voltage, the magnitude of input voltage, that is by Vs. Okay, then go for the calculation of periodic signal, that is defined by V0t, okay, from the Fourier series. And we can, as this is the half wave symmetry, as we know the output voltage is similar to this one, that means this part is similar to this part, that is called half wave symmetry. And if the further we will go for the next cycle, that means we have taken only the odd harmonics 1, 3, then 5, then 7. That is why here we are considering the n equal to 1, 3, 5 to infinity, Bn sine n omega t, as it is a half wave symmetry. That is why A0 equal to An equal to 0 for Fourier series. So this is the expression where we can determine the coefficient of Bn by this expression. That is Bn equal to 2 by pi integration of 0 to pi V0t sine n omega t d omega t. Okay, simple, the calculation process is given here, that is 2 by pi integrating of 0 to pi Vs sine n omega t d omega t. Then after simplification, we know the integration of sine n omega t, that is minus cos n omega t, and integrating of the n, that will give you 1 by n. I have done here, that is the equation will change the new form, that is 2 by pi Vs 1 by n, and the third bracket minus cos n omega t 0 to pi. And considering the limit 0 to pi, that is cos 0 minus cos n pi, as it is a symmetrical, half wave symmetrical nature. That is why we should consider the odd harmonics only, just I told you before. That is why all the cases cos pi, cos 3 pi, cos 5 pi, it will give you the minus 1. So we will get the result, that is 2 Vs 1 minus minus of 1. That is why we will get the result of the coefficient Bn, that is 4 Vs by n pi. In case of half bridge inverter, we have got the result that was 2 Vs by n pi. But here we will get the result, that is 4 Vs by n pi. That means the magnitude is higher with respect to the previous one. That is the benefit for using full bridge inverter for the industry purpose. Now that means the output voltage magnitude is high with respect to the half bridge. So we can put the value of the coefficient in the main equation for periodic signal, which is defined by V0t equal to n equal to 135 to infinity 4 Vs n pi sin n omega t. Okay, so the output equation for the current, that is equal to, as the resistive load R load is there, that means we can say R load is there, then the output current I0 by I equal to V by R. Okay, that means 4 Vs by n pi R. So this is the output equation. So this is all about for the operation and the equations. Thank you.